Hello everyone, this is Malik, and on behalf of Couchbase and 451 Research, which is now a part of S&P Global Market Intelligence, I would like to welcome you all and say thank you for attending today's webinar titled Why Your Modern Applications Won't Survive Without a New Database Foundation. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen. We will get to as many as we can during the Q&A session. The presentation slides are available for download in the resource section in the console. And finally, the on-demand version of the webinar will be shortly available once the live event concludes. Leading off today's discussion will be Matt Aslett, who is Research Director at 451 Research. Joining Matt will be Jeff Morris, who is VP Product and Solutions Marketing at Couchbase. You can learn more about Matt and Jeff by checking out their bios on your screen. And with that, I'll turn it over to Matt to kick off this session.
Thanks, Malik. Thanks everyone for joining us on this webinar. Bear with me a second. I think I'm having some technical problems. I'm just loading up into another browser so I can actually push the slides forward. But I'm going to kick things off here talking about, obviously, application modernization, data modernization, and the context for all of that is obviously digital transformation. And I suppose the first point that we would make, from our ongoing research and and surveys is that digital transformation is definitely something that is real. I know it's something that a lot of companies like to talk about, and I think it's one of those topics where you see a lot of people kind of rolling their eyes as soon as people start talking about it. But a lot of companies are actually doing something about it as well. As you can see from this survey, close to 50% of organizations that we survey are actually not just doing something about it, they're in the execution stage. They have a formal strategy, and they are actively digitizing their business process and assets. And an additional almost quarter of organizations are in the evaluation, planning, and researching and developing that strategy. So this is very much something that, not all organizations, but a significant proportion of organizations are actively doing something about. Additionally, we do see that it's something that companies are having success with. As you can see here, about 3/4 of organizations, again, of those that are actually, in the process of digital transformation, say they have seen success with that. And just under 10% say that project has been completely successful. So, of course, the devil's in the details. Digital transformation is clearly much easier said than done, but it is something that is delivering success for a significant proportion of organizations, especially, obviously that we're seeing in our surveys. What we also see, excuse me, is that a large part of digital transformation is application modernization. And, you see as businesses try to modernize, try to change the way they engage with clients, try to change the way in which they deliver information and services to, both to partners and employees internally. A significant proportion of the applications that the businesses are dependent upon don't just have the potential to be modernized. They actually, there is a requirement for those to be modernized. So nearly 69% of organizations tell us that between 1/4 and 3/4 of their application workloads require modernizing to support evolving business requirements. So that's a significant proportion. As I say, it's not just therefore about a desire to do things differently, to operate differently as a business. It's actually a requirement to evolve the current infrastructure and applications in order to support evolving business processes. And I know we've had a question come through already about transformation of what to what. So, we're talking here about businesses. We'll hopefully provide some good examples as we go through here that put some context on this about what we see different organizations are trying to do. If not, obviously, do come back to us for the Q&A and we can talk about that in more detail. there are multiple ways, of course, in which organizations can look at modernizing their applications. What I think is significant is we see that, as you can see here, 83% of respondents from our Voice of the Enterprise Digital Pulse survey tell us they are planning to update their existing mission-critical applications. A lot of that is about modernizing the existing applications on premises. Perhaps in particular here, we talked about sort of adapting them to more of a cloud-native architecture. But also, clearly the public cloud has a key role to play here as well. And we see, 29% are talking about refactoring and shifting applications. So that, again, rebuilding, modernizing the application itself to work in a more cloud-native architecture and then deploying on public cloud. And then we also consider here in terms of sort of modernizing or updating, repurchasing, so purchasing a newer version of an existing application or developing a newer version of an existing application that is deployed on the public cloud rather than on premises. So there's a whole different way in which organizations are approaching this. And what we've seen is, in particular in the last 18 months, there's really been an acceleration for not all, obviously, but for some organizations around the way in which they engage with customers, the way in which they engage with employees, and drive to accelerate many modernization initiatives. Obviously, from an employee perspective, we all, or almost all of us, have been, working remotely, working from home. So enterprises have had to adapt some of their applications or think about adapting some of their business processes to reflect that. In particular, we've seen this obviously in from a customer experience perspective. As you can see here, top of the list, over a third of organizations say they've actually accelerated or newly introduced the shift to digital delivery of customer experience. Clearly, from a retail perspective, there was a period at least where, we as customers were not able to walk into many retail establishments. That's changing now, but obviously a lot of retailers had to adapt to that. Some were well positioned to adapt already, and some had not done any work at all in terms of responding to the need for sort of curbside pickup or delivery to local or international addresses. So there has the COVID pandemic has really accelerated for, as I say, not all, but a significant proportion of organizations, the work that they're doing to transform their applications. We also see, overall digital transformation has been accelerated for around a quarter of organizations. Migration of workloads to cloud has been accelerated or newly introduced for, just under a quarter. And, data and analytics, slightly below there, but 12% of organizations saying they've accelerated or newly introduced data and analytics projects. What we also see is that, these things are all kind of tied together. Data and analytics modernization is often, part of a larger transformation project and clearly has a role to play in customer experience and digital delivery changes. As I said, customer experience is a transformation priority. If we look, generally speaking, especially this has been true in the last 18 months, but generally, even before that, when we ask organizations what is the number one priority or driver for their transformation of their business, improving customer experience is always the top priority. And also we see, that there are some significant technologies that are influencing that transformation as well. Cloud, already mentioned, is obviously one of those, just the rejuvenation of the overall IT estate, but also and these have significant implications, particularly as it relates to customer experience. For example, the emergence of and rollout of 5G technology changes the expectations from a customer perspective in terms of what their expectations around experience. IoT, obviously we see a lot of enterprises now driving new data-driven experiences based on the collection of data from devices, products, and that, driving both internal projects, providing employees with greater views of what's happening out in the world with customers using their projects, but also potentially to the customers themselves, understanding the way in which their products are being used, how they can improve the efficiency, perhaps from a utilities perspective, for example, and overall driving improved customer experience. And then AI, ML, obviously a key part of many emerging or new application development projects, in terms of particularly driving things like predictions, recommendations, and targeted offers, for example, from a consumer experience perspective. So what we've seen, I already sort of touched on this, is that these are four key areas perhaps where we see significant growth and a significant influence over the overall transformation of business. And they all influence each other. Digital transformation is fueled by customer engagement and cloud migration. Data analytics in particular, fuels customer experience. Also, data and analytics workloads are being pulled to the cloud increasingly by overall migration projects, many of which are driven by digital transformation. Obviously, data and analytics has a role to play in helping organizations understand opportunities to transform and improve their business as well. So all of these things are wrapped up together, and you can think about this as really sort of having a snowball effect on the extent to which organizations are looking at altering or having to respond to the requirement to alter the way they conduct their business. So to pick out two of those in particular, I already touched a little bit on this: customer engagement and data and analytics. Clearly, you cannot really improve how you engage with customers without understanding those customers, and the way you understand those customers is data and analytics. So we see that data and analytics is the number one initiative historically that's been utilized to improve customer experience. Understanding which products the customer has, but also, especially if we talk about, now that many of the rules are changing after the sort of COVID lockdown. Understanding and trying to predict how customers will behave in store. Will they come out to the stores in the same way that they did before? What proportion of their kind of engagement is going to be through digital channels? Is it a mix of both? And how you can understand, based on different products and different industries and different types of customers, how that will evolve. We also see that, of course, customer service and engagement is a key benefit of being more data-driven. As you can see, and this is from our most recent survey when it came out second in the list, and it's been interesting, actually, the surveys we've done over the years. It's always, I think I'm right in saying, increasing sales and enhancing customer service and engagement are the top two, and they kind of flip around from survey to survey. But, they're always right there at the top. That is one of the primary advantages that enterprises are trying to gain from by investing in more data-driven decision-making, driving greater engagement with customers. And of course, that results not just in the modernization of the application estate, but also the modernization potentially of the underlying data platform estate. And we've seen from our surveys that a good 62% of organizations said they are planning to modernize or update their existing data platforms. Again, much of that, a quarter of respondents saying that is happening on premises. There are multiple reasons we won't go into now, but why organizations potentially want to keep workloads on premises, but they are looking at cloud-native architecture. They're looking at new approaches to data processing, and they're looking to potentially modernize those data platforms at the same time as they're obviously modernizing the applications, as we talked about before. Again, of course, some of that is happening in the public cloud, whether that's repurchasing a newer version of an existing database that's now running in the public cloud, or reworking the whole application data platform stack and obviously migrating that or adopting a new version of that in the public cloud as well. So again, there's multiple approaches to this. Overall, the impact is on the modernization of both the application stack and the underlying data platforms. So we Also, so that previous survey we did was from last year, and we were very much focused there on the location of those workloads. This year we asked a similar question, but we were more focused on, well, what is the actual database? And we asked, if we take an assumption, which is, I think, a fair assumption, that the majority of existing data workloads are on an on-premises relational database. And certainly we see from our surveys that while that is changing, that has been historically obviously been the case. So what is happening with those on-premises relational database workloads? Well, a significant proportion of those will remain on that or with that current relational database supplier, although potentially in a different location. Some of those are going to be migrating to a different relational database supplier, but a healthy proportion of those, you see here nearly a third of respondents expect to migrate existing on-premises relational operational workloads to NoSQL databases. And this is something we've seen is a growing factor when enterprises look at their database estate and their application estate. Obviously, in the early stages of NoSQL adoption, much of that was driven by developing new applications that perhaps weren't suitable to the relational model. Increasingly, as features and functionality have been added to the various products in the NoSQL space, they have become much more suitable for taking on some of the workloads that historically kind of just been deployed on the relational databases by default. And so if you look at that in more detail, the way we talked about this over the years is the sort of the scale benefits of NoSQL databases. And scale obviously literally refers to scalability. NoSQL databases designed, most of them, specifically to operate in a distributed cloud architecture. But also it's an acronym, and you can see, the other elements of that. So cost, either, freely available as open sourced or as, low cost, both through licensing or through managed cloud services. Availability across multiple environments, on premises, multiple clouds, but also high availability has obviously been a significant factor in the development of NoSQL databases and the underlying architectural approach to NoSQL databases. Low latency as well in terms of rapid response times. And also elasticity. So not just scalability in terms of the ability to scale out, but also clearly the ability to scale back in. And you can look at those elements of have also had a role to play clearly in the evolution of other relational databases in recent years. But there is a difference, I think we've seen historically where the NoSQL databases were developed obviously more recently with those factors top of mind, rather than trying to bolt on capabilities to an existing database to make them more suitable for a distributed cloud architecture that we see organizations using today. Now, the interesting thing, as I said, is in addition to those sort of design points, what we've seen is that many NoSQL databases, some more than others and some in different ways, but so obviously always check the small print. But as a generalization, we can say that many of them have added support for attributes that we would traditionally associate with relational databases. So things like support for SQL or SQL-like languages in some cases, support for transactions, and support for relational structures. And I think this is why we now see that there is this potential significant impact in terms of, as we saw there, 29% of organizations saying, potentially their relational workloads or some of their relational workloads might move to NoSQL databases, because when you put, the scalability benefits of the inherent design points of NoSQL together with some of the obviously important capabilities that are traditionally associated with a relational model, then you've got a database, a data platform that is designed to support the modernization of applications based on some of the key trends that we talked about earlier. And another key point here is that we see is it's not just about I mean, frankly, NoSQL was always a bit of a misnomer, but it's not just about SQL or NoSQL. It's not about, relational or non-relational. It's not about, is it, a key value store or is it, a graph database or a JSON database. Increasingly, we see that databases are, across the industry, whether they're relational or non-relational at heart, are able to support the storage and processing of data using multiple models. And this is something we see that increasingly enterprises are actually not just interested in, but actually have a preference for. So 81%, as you can see here from this survey we conducted late last year, 81% of respondents said they agree with the premise that their organization has a preference for databases that can support multiple data models, relational, key value, document, graph, spatial, time series, etc., rather than using multiple dedicated databases. This is something we've seen evolve very rapidly over the last couple of years, both in terms of the actual functionality itself, the ability to support multiple models, but also in terms of the customers and their willingness and understanding of the role that these products can play, and their willingness to adopt them. So that was a pretty rapid run through of, obviously a bunch of different trends, and it talks about how we see all these things colliding. So that we were only able to sort of touch on, some of the key trends there. But hopefully, obviously we'll be going into more detail and happy to answer any questions. But just to focus on sort of the key takeaways, if you like. The first, as I mentioned right at the top here, digital transformation, data transformation is real, and it's also delivering success. And importantly, I think quite often we talk about the desire of companies to modernize their application estates, in order to respond to customer demand for new features, functionality, for example. What is really interesting, I think we've seen that in our more recent surveys, is the proportion of existing applications that actually require modernization to meet the business goals. And that is really having a significant impact, and we've seen that obviously accelerated in the last year or so. We looked at, there's multiple drivers for that. As I said, obviously customer experience and engagement is one of the key drivers, in many cases at the top. And also we see there are multiple emerging, or some more emerging than others, if you like, technologies. Cloud obviously continues to have a significant impact. 5G is obviously newer, and we anticipate having a significant impact to come. IoT, AI, ML. Obviously, in some cases, that's already a significant part of the application design and requirements. In others, the need for those kind of capabilities is just emerging. Either way, they're driving new modernization requirements. And we see that obviously the application requirements have a knock-on effect on new approaches to data processing and also data platform modernization and, potentially replatforming. And that is what is driving the adoption of modern data platforms that can support, in particular, as we just mentioned at the end there, multiple models, multiple data formats, giving organizations, the ability, agility, to be more responsive and to support, develop applications that can deliver on the capabilities that customers and employees, expect. So with that, as I said, more than happy to take questions and go into more detail as we get to the end of the session here. But for now, I will hand you over to Jeff, obviously, to talk about Couchbase in particular and how it sort of, fits in the scenario that I've just described.
Thanks so much, Matt, and welcome everybody. We're very excited to continue this conversation with Matt. And what I really want to talk about is from the Couchbase perspective, how we're actually seeing some of those requirements that Matt just laid out, how those are playing out in the real world. So we've been, throughout the course of 2020, been in huge amounts of discussions with our current customers, and what we found is and collected is a series of core requirements for modern applications. And this helps cast or characterize the types of transformation that our customers are looking to perform or looking to do. And you can see that when we kind of bucket or sort these particular sets of requirements, they form themselves up into a particular type of package or a particular style of application. Number one is to deliver exceptional user experiences to your clientele. And the clientele, most frequently is a customer base, but it also is, for large organizations, can be their employee base, right? Field service is a very, very popular type of use case, and as you can see, our example is very much so mobile powered. And what Matt had just described is that what's going to end up happening is 5G enabled environments are going to be are going to proliferate much more rapidly over the next 18 months or so than they have already thus far. And so these 5G enabled environments, they happen to have a bunch of common attributes. They're intelligent, right? They're very, very fast and responsive to that particular user. They're, as I said, they're highly personalized and geared towards applying whatever intelligence you happen to have about that particular user or consumer, but applying that directly to their experience in real time, in the moment. And that's really what Matt had discussed earlier in the application of data and analytics into the digital transformation exercise. I think we've previously seen that analytics is sort of one database exercise, and operational and transactional application delivery is another part, is the other half of the database experience. But what we're starting to see is not only that original multi-model approach that Matt talked about, but also a convergence of these kinds of the blending of analytic with operational capabilities. Now, when you deploy these kind of environments, right, as I just mentioned, we've got to deploy inside of a 5G enabled kind of network. And that has its own interesting anomalies, like networks are oftentimes not that reliable, yet your application still needs to be. We do want to continue to support 100% uptime as at global scale, because your users are often going to be worldwide. We need to provide very solid management capabilities for the administrators, and as cloud drives much more of our business forward, be cost efficient and cost effective in this endeavor. And finally, for the development audience, the people who are actually applying or creating the intelligence in these kind of innovations, in these inventions, is support modern development practices. So improve the ability to support cloud native continuous integration and continuous delivery type type delivery models in a microservices based environment in the cloud. But that's the modern part of what application developers are attempting to do. Yet at the same time, we want to tap into their previous experience and all of what has turned them into the developer of today. And as Matt mentioned, oftentimes that includes allowing them to pick their specific languages that they would like to use and support the things they already know, like SQL. And ultimately, under that multi-model umbrella, one of the drivers that when we talk to customers, one of the drivers that we see regularly is they want to consolidate and avoid database sprawl. If I were to characterize, as I move forward, if I were to characterize kind of cloud deployments in the first generation, is when you saw AWS build out all of their different database products. They have nearly 20, maybe 24 different database products available in their service. And each one of those supports a particular type of development model or data access model that's appropriate for a particular type of job that the development team is trying to accomplish. Now, so that kind of support for an application built up, atop multiple databases is just wrought with complexity and too many APIs, too many interfaces to deal with. And that's one of the reasons why this convergence into multi-model systems is gaining speed right now. So when we see and look at these kind of databases, we recognize that these requirements, the database requirements have changed as well. So not only on the NoSQL side, which is certainly where Couchbase was born, support, as Matt just laid out, support for massive scale, support for performance and flexibility, and cloud native design and architectures. Those are the key drivers that are making NoSQL databases popular. But then carrying forward with the traditional trusted capabilities of relational technologies, the legacy types of demands, like being able to support transactions, having transactions work inside the query language, and supporting ACID properties throughout the environment, being efficient with your storage, being efficient with your scale, and being efficient with the structures that you're able to offer your development community, such that they can design and build a well thought out system. So when we sort of packaged that up, we found that there were really 4 reasons why customers were seeking out Couchbase, or are seeking out Couchbase, and asking us for assistance. Number 1 is their existing applications are failing modern day performance demands. Matt had mentioned earlier that the behavioral changes due to the 2020 pandemic. User behaviors changed very dramatically. Users went decentralized. They all went home and locked down. That put new stresses on applications. So if your application was only serving, a few thousand sessions, a week or a month, that might be tens or hundreds of thousands of sessions during pandemic, because everybody moved to online ordering and delivery of groceries, right? Which is something traditionally we wouldn't necessarily be doing. So the back end systems that are supporting these things are suffering from the stresses of this even greater shift to online activity. While they're doing that, there's also these change in requirements. And what we found is that certainly relational systems that have more rigid schema are not able necessarily to support the flexibility demands of these new applications. They may need, if you need to add tables or even columns to tables, that could take weeks or months to do in a traditional sense. But what the demand that we saw in the beginning in 2020 was that applications needed to change week by week, and allowing the application itself and the developer to change the structure of the data or add attributes of the data while they're collecting more and more profile information or personalization information about their participants. That activity really requires something like a flexible data format underneath the overall system. Of course, that's why a system like Couchbase and others support JSON as your document format, because it's very, very easy for the application to modify the attributes that it's collecting. This delivery of mobile experiences is booming right now, and that's that will continue, because that's where the online experience is happening in your user community. And all of this has got to happen, with the initiatives to move to cloud or others to really drive down total cost of ownership. There's no longer any tolerance for highly expensive, difficult to maintain systems. So we look at our install base and the folks who are actually indeed using Couchbase from a standpoint of how they are looking at how they're approaching their own applications. FICO, for example, is helping financial services institutions identify fraud across their networks, across their credit card transactions and other activity for nearly 9,000 banks. It's an incredibly large system. They're covering, using Couchbase, 3 billion plus accounts, right? Those are profiles of accounts, so that they know, my particular banking account with Bank of America, most of my activity happens in the San Francisco Bay Area, but sometimes I travel. And they're keeping track of those kind of occasions in within my profile. Carnival is a customer of ours who's actually a kind of one of the originators of this high-touch user experience kinds of deployments. They characterize their cruise ships as smart cities. And what they're capable of doing on any cruise is helping enhance the passenger experience by attaching a wearable device that allows them to feed information across the ship while the passenger is interacting with crew members, while the passenger is performing activities like having meals, or even just hanging out by the pool. One passenger might need to find family members, and they can look that up on an app directly within their experience. So all of that is being powered by Couchbase, and you can imagine that even during times of stress where supporting customers who congregate all over the place is challenging, they're able to also do very, very clever things like contact tracing and like making sure that they know where issues might be landing and who's affected by that. LinkedIn, again, a caching system of high-performance caching to support that increase in online activity, and ultimately in Staples, right? It is the back-end side of creating a highly personalized experience based on attributes you might know about a participant or a customer. You also oftentimes have to match a very complex product catalog to that, to meet the particular expectations of that shopper or of that user. And so what we see, that flexibility that I mentioned about JSON is really helpful in that, in those kind of environments as well. And you can see that these types of requirements for high degrees of personalization, matching to very complex product offerings and catalogs, this happens across many markets, nearly every market. Whether it's in retail, that one's what I was just talking about and sort of obvious. But travel and hospitality and loyalty programs is another huge area where that personalization and understanding your customer, your user's needs is really important. The fraud detection and seeking out unusual events in financial services, in healthcare, right? Making sure that you're able to both secure a patient profile as well as provide top care. We have customers like Backpack EMR, who is able to support and create pop-up medical clinics wherever they need to be, and they're doing so with using Couchbase technology as that pop-up emergency medical record capture and delivery system. But in telco and media, it's media streaming. In gaming, it's keeping track of progress within the game. And in IoT, it's support of this smart mesh of devices, making sure that they're online, making sure that the experience itself is remains interactive, even when a network might cut out because wires fail all the time. But all of those are instances of where this high degree of personalization, driven by a dynamic profile, matched to products and services that organizations might be offering, is really the sweet spot of what these modern applications continue to look like and are going to look like in the future. So what we're helping customers end up doing in terms of these types of use cases is, first assess what their goals are, whether they're looking to make their customers happier, deliver, make sure that they're able to capitalize and drive, speed to market. Making sure that we're able to support those cost savings initiatives without sacrificing any of these performance or functionality requirements across all of these different types of basic use cases. This is how we do this, though, is when we look at how we're going to end up helping these customers modernize their applications, we're going to look at how we can help you develop faster in the space, deploy your applications wherever they need to go, and make sure that this is highly responsive and performs at scale. Those are really some of the core benefits of traditional Couchbase capabilities. But some of these are, actually incorporate a lot of what Matt had talked about earlier, like being able to make sure that we're supporting a wide variety of data access methods, whether it's supporting a key value caching style system and operating in memory to support very, very low latencies when we're performing activities, being flexible with the data format underneath as a document data store. Supporting relational database-like controls and structures. Most recently, Couchbase came out with version 7 of our flagship server product, and we added these new relational friendly data structures. We call them scopes and collections, but they really map towards schemas and databases and within schemas and tables. And then within a table, a document is like a row. So these new structures allow you to really organize and streamline the performance of data inside of Couchbase. And as I said, that's brand new. And then there's supporting SQL query structures as well, and syntax as well. And I'll show you an example of that where you can't tell the difference between what's in MySQL and what's in a query that's written for Couchbase. But then there's also supporting full text search for like geolocation kinds of searches, or being able to react to event changes in the database or support change data capture using an eventing service, or performing those real-time analytic capabilities that we've mentioned, like creating a real-time offer based on information and analysis that you're able to perform immediately, but and performing that analysis without impacting the overall operation of the rest of the system. Isolate the workload for analytics in one set of nodes and allow another set of nodes in the cluster to be supporting different, the operational parts of the application. Mobile, I keep mentioning, and enterprise level security, which, things like supporting role-based access controls that operate up and down the data structures, like supporting TLS encryption, throughout the environment, or supporting encryption at rest on mobile devices and other areas where data is going to be sensitive and potentially exposed. All of those core capabilities are really, how we end up approaching, helping a developer build systems faster. So we really look at ourselves as this modern application for a modern database for enterprise applications, and our the multi-model support that we promote very regularly is being that document data store, but now adding relational structures and familiarity, including the SQL query language, as well as transactionality in that query language. Supporting key value capabilities for very, very high speed in-memory processing. Operating as a full-text search engine, most applicably in support of geolocation, or just free-form search inside of the database. And like I said, supporting real-time analytic capabilities with this workload isolation kind of functionality. So a large-scale analysis job that might get kicked off does not interfere with the everyday operation of the rest of the system. Now let me show you how, and as I mentioned, this is our query language called Nickel is really SQL for JSON. And so anyone who knows everyday SQL will be very, very familiar and very, very Couchbase literate in about 3 or 4 minutes. And as you can see, it has the benefits of being a declarative language, so the database will take care of figuring out how things should be executed, and that's unlike other query languages which are imperative that really require you to dictate exactly how the database behaves in fetching the information you want, rather than just making the request, as is kind of the tradition with SQL and carried forward with Couchbase. But as I mentioned, some of the latest capabilities that we've added in are transactionality inside of the query language itself. And this can happen, operate across multiple documents all at the same time, and supports, a high degree of capability in here, where you can set breakpoints and you can set commitment statements, and make sure that the transactional structure that you're looking for is indeed what you expect to have happen inside of the database. And all of this is supported through the query language. So let me show you what that really looks like. So if I take a simple transaction, almost something like I was showing a moment ago, I've got my update statement. I'm looking for the ID, name, balance from the customer. I update those records, and then I commit the transaction itself, update the balance, etc. And you can see that the relational structure and the Couchbase structures are identical. But let's get a little bit more sophisticated and say, all right, start a transaction, have a save point, set a rollback point, and then commit the transaction. Again, identical to what you would expect out of SQL is how Couchbase supports these capabilities. And what we're really seeing is, we know that there's a developer shortage in the market right now, but yet these digital transformation exercises need that institutional knowledge that our SQL developers have innately inside themselves. That needs to carry forward into this digital transformation process and into these modern applications. And that's really the big point of why we make such a big deal about supporting SQL, is because of those needs. So when you look at the kinds of transactional use cases we're able to support, catalog support, ordering, inventory management, supporting purchases, quotations, supporting integrations with billing systems, and then supporting payments on the other side, the financial transactions, or building out bills of material, supporting inventory and production control, supporting shop floor controls, and ultimately also supporting human resources and customer resource management kinds of applications. All of these have transactionality built into them, and the expectation and trustworthiness of transactionality that came from relational databases is now a part and parcel to this overall Couchbase offering. So the way we really characterize it, and this is one of the great lines from our CTO, is look, the debate between relational and NoSQL databases is over, because the choices used to be, I'm bound to the inflexibility but transactional and dependability of a relational system, versus the flexibility and scale without that transactionality or without that consistency of a NoSQL system. But actually, Couchbase has fused those two things. So we've really married up and brought together the strengths of relational along with the flexibility and performance of NoSQL into a single platform. And that's where we see the that kind of convergence is going to both continue and drive become the foundation for these modern applications, as we've been talking about. So one of these other elements that I was discussing that we rolled into Couchbase Server version 7 is the scopes and collections idea. And I'll give you a sense of what that really means and where we put it and some of the impact that it has on the performance and operation of the database. These are two new logical data structures that we've inserted in between what we traditionally characterize as a bucket. That's kind of your database definition. And then the documents that live within the bucket. Now we have two new organizing structures in between those to help us both secure, improve performance, improve data isolation, and for multi-tenancy, for database sharding, for data rebalancing. All of those benefit from this new introduction of scopes and collections, because most of the operations previously that we support happened at the bucket level if they were multi-document operations. Now they all happen at the collection level. So we've pushed down and made more granular the activities that we support, and there's some really, really big impact results that come out of this. For example, the global secondary indexing capabilities of Couchbase are now much, much faster and much, much more high performance, even though they were high performance at the beginning, because they're now granularly attached to a collection rather than at the bucket level. So you can imagine when your indexes are smaller, they're faster to traverse, and therefore they'll deliver faster results to you. And you can have 10,000 indexes in a cluster, so it's not like you're giving up any of the scaling capabilities here. But for developers, we give you these new organizational structures. For admins and DevOps, we give you a way to support a variety of multi-tenant kinds of deployments. And for architects, we still support, and DevOps, we support high degrees of replication, microservices style delivery where a collection could be mapped to a microservice. And because the collection is, will deliver data on demand to the microservice, it's really helping blend that stateless microservice operation with stateful data that's stored inside of Couchbase. So our next one is deploy everywhere. And really what I want to end up talking about here is this notion of multidimensional scaling that allows Couchbase a Couchbase cluster to be performance tuned to match the requirements of the application itself. And when I say match the requirements, match the application requirements to the underlying infrastructure upon which it's running. As I mentioned earlier, that the analytics service really benefits from this because analytics could be a highly CPU, highly memory-intensive activity. So you want to assign that to a particular node or a pod in your cluster. Whereas the query and the data service, you want to have operating across many nodes because that's really the bulk of the services that the database is performing. But you can also use particular nodes for full text search or eventing or the backup service or indexing as well. And all of these are aware of these new data structures, this dynamic data containment model called scopes and collections, and operate across any size cluster. And then so you mix and match that with both our cross data center replication capabilities, as well as our autonomous operation capabilities supported by our Kubernetes wrappers. We've got a very, very easily, very cloud native, very cloud portable a set of functionality to be deployed wherever you need to put it. Now, modern day applications really, are oftentimes are seeking, very cloud native technology and being deployed either as a service. So we manage the system for you. You simply write the application and store and maintain your data. Or if the more traditional in a hybrid or a private cloud kind of environment, you can self-manage this by yourselves. And using those Kubernetes capability in what we call our autonomous operator, very, very easy to manage and drive. So as I mentioned, cross data center replication, and this operates all the way out to mobile and edge style deployments. And we actually have a product called Couchbaselite, which is an embeddable NoSQL database that synchronizes not only amongst our synchronization gateways, but also peer-to-peer amongst other Couchbaselite instances. So we believe that this really supports our offline first kind of approach to mobile. And as I mentioned, that workload isolation, optimization here for with what we call multidimensional scaling. And finally, when we look at how this performs against whether it's relational or other systems, fundamentally I'll race anyone in terms of supporting a growing set of users, a growing set of data, and keeping costs growing at a predictable rate. We've exercised the product countless times in the last couple of years, and what we find is our memory-first architecture really helps drive our performance gains, and this is proving out in standard types of benchmarking exercises like the Yahoo cloud serving benchmark that is sort of the NoSQL standard for test driving systems. And finally, in terms of reliability, right? Every node in a cluster, does indeed have support continuous replication amongst nodes for failover and backup and availability. And the rebalancing exercise, if you need to expand or contract the application, is all supported within this environment as well. So, and finally, the capabilities that we put into Couchbase 7, indexing is incredibly much faster. Failover is much faster. We built a new consistency management library called Chronicle, which is a RAF-based consistency manager that made lots of our internal operations run much more quickly than previous versions of Couchbase. So as I wind down, and I want to take a couple of minutes for questions, some of the key differences will support, for developers, the familiarity of what you know in the past from your experiences in relational technologies, fused with the flexibility of Couchbase as a NoSQL system. This, for architects, the architecture itself is very high performant and allows you to, as I mentioned, isolate the workloads based on the requirements of the applications. And for DevOps, if you're managing new systems in the cloud, we support all of those cloud native style deployments and techniques, including support for microservices based applications or support for CI/CD delivery practices. We do offer a complete set of services and training to help you get through each sort of phase of development and delivery of your application. And ultimately, delivering that sort of reliability and dependability of a traditional relational database, as I mentioned, fused with the core capabilities of a NoSQL system. So across the board, for every audience member that might be here, whatever your particular concerns are, there's some really incredible capabilities that Couchbase supports that should be investigated and dove into. And again, this is all in a single data store. Finally, the way to look at this when you compare it to both a relational system, compare it to a popular other NoSQL system, the core flexibility, Couchbase has structure on demand. Couchbase has, as you need it, use of a declarative query language, SQL, yes. Transactions inside that SQL, yes. Sub-millisecond latency, absolutely, due to our in-memory processing. Elastic cluster scaling, certainly. Overall high availability, disaster recovery, multimodel support, locality support, and finally mobility. Right? These are all some of those core requirement drivers or capabilities that we started out with at the beginning of this particular event. So with that, I'm going to start to open up for questions between Matt and Malik. I do want to give a plug very quickly for Couchbase Connect Online, which is happening. It's our online conference. It's happening October 20th and 21st of 2021. And you can register at connect.couchbase.com. It's a free event. It'll run 2 days. We've got more than 80 sessions already laid out. There's about almost 30 sessions from customers. So this is going to be a really, really good event to familiarize yourself with other modernization techniques that our customers are taking on and using Couchbase for. So with that, Malik, I'll let you kick off with some questions here.
Thanks, Jeff. It's now time for our Q&A session. Just a quick reminder, if you have a question, simply type it in the question box on your screen. First question, Jeff, I think this is for you. It says, can you quantify how much faster Couchbase 7 is, and what did you do to make it that way?
Well, as I mentioned, so Couchbase 7 is very likely going to be anywhere between 30 to 50% faster when we compare it to 6.6. A lot of that is born from these capabilities that we put in of pushing down a lot of database operations to the collection level. And a lot of it is also due to that library, that consistency library I mentioned called Chronicle. And what Chronicle really does is manage the metadata about the database in a much speedier way. It uses less memory. It uses, takes up less time to make sure that changes are delivered across the cluster, and that in turn makes the overall cluster faster. So those rebalancing exercises, failover is faster, indexing is going to be incredibly, index operation is faster, index builds are faster. They're built in parallel now instead of serially. So you're going to see quite a bit of boost in turbocharging of Couchbase Server 7.
Thanks, Jeff. That concludes our webinar for today. Thank you, Matt and Jeff. As a reminder, the on-demand version of this event will be available shortly on behalf of Couchbase and 451 Research. Thank you for attending and have a great day.